Good afternoon. Thank you for joining us. My name is Vasudha Sridharan, and on behalf of Cumulus Networks, I'd like to welcome you to the Open Networking for Hyperconvergence webinar. We have three presenters today. Doug Youde, who is our CSE from Cumulus Networks, is a seasoned cloud solutions architect with experience in education, service provider, and vendor arena. As a customer solutions engineer, he helps customers successfully architect and deploy scalable, cost-effective SDN solutions using Cumulus Linux and offerings from ecosystem partners. We also have Michael Webster, who is a senior solutions and performance engineer at Nutanix. He's a Nutanix platform expert, a VMware certified design expert, vExpert, and the co-author of Virtualizing SQL Server on VMware and author of the longwhiteclouds.com blog. We also have George Hewitt joining here from Sydney, who is the infrastructure and development manager at Perth Radiological Clinic. This webinar will be about 30 to 45 minutes. We will answer a few questions from the participants at the end if time permits. For those of you interested, you have the opportunity to ask questions during the webinar by using the window marked questions. Simply type in your question and click send. You can also tweet your questions to us. Our Twitter handle is @CumulusNetworks. And with that, I'd like to turn this over to Doug.
All right, well, g'day all. So I guess to start with, I'm going to tell you a little bit of a story about how we kind of met and how we started to put together a solution, literally the back of a napkin in some cases, and kind of take a little bit of a step back from there and actually show kind of how the three of us actually met in the first place, how basically two Aussies, a Kiwi, and a bunch of storage vendors can walk into a bar in San Francisco about a year ago, and how this all works out. There's also a Frenchman who decided to record this whole thing. So if anyone wants to rewatch this later or is having trouble following along, you can rewatch it later as well. So yeah, as I kind of said, two Australians, a Kiwi, and a bunch of storage vendors basically walk into a bar.
Can everybody hear me?
I can hear you.
Okay, cool. So we've got Michael and we've got George, but it looks like we've lost Doug, unfortunately. I guess I'll take over and start telling the story then. So as Doug was saying, we all walked into a bar in San Francisco, and I was over there with a mission from work to find a new storage solution for our old aging SAN and our compute. So just so happened to be that everybody in that room pretty much was storage vendors and worked for a storage vendor or had some experience with a storage vendor. And so we were throwing around ideas and talking about what was different, what was new, and what was a different way of doing it, and also what's simpler and could, make things a lot less work for me. So I ended up talking about Nutanix, which is an amazing hyperconverged platform, which is incredible in terms of simplicity and ease of use and scalability, and performance is amazing as well. So that was when we started talking about that kind of thing, but obviously when you get a platform like that, you need something to hang it together. A hyperconverged system like Nutanix doesn't actually use fibre channel, such as a regular SAN, but it uses Ethernet. So just so happened to be that Doug worked for Cumulus, who do Ethernet really, really well. So we ended up talking to those guys, ended up talking to Michael, and we came up with a bit of an idea of what we could do. So yeah, that was the brief story of that. I don't know where else Doug was going with that. Is Doug back in yet or not yet? Doesn't sound like it.
Do you want to go to the next slide, please, Doug? There we go. Rightio. So this is a photo actually taken from the prime we were at the time, talking about all things storage, hyperconverged, compute, networking. And from a Nutanix perspective, it was great to meet George, a potential customer, and also catch up with Doug and his other half, who's in a storage game as well. And just talking about how things are changing in the IT world and how scale out is really impacting a lot of different things and making the whole world And then our software networking is also doing the same thing for networking as what we're doing for compute and storage. So one of the main benefits that we see at Nutanix for using Cumulus is that it just makes the management of the underlying fabric that basically is every piece of information completely simple, easy to manage, scale out. And I think this has pretty much been your experience, hasn't it, George?
Yeah, it's great. In terms of just being able to simply manage a network and storage and compute all pretty much in one spot is just amazing for time saving. We just stood up an Exchange environment 2 days ago, and there was no requirement from anybody other than the actual server guy, like the Windows server guy and the Exchange guy, because they could just spin up machines, the storage was there, networking was there. It was just so quick and easy for us to do.
One of the things that you've actually done is automate the process of creating new VLANs and things on switches.
Yes, that was
and everything.
Something.
Show us a video of that.
Yeah, I'll show a video of that in a sec. But yeah, the idea was, I think the next slide may explain it. If we can go to the next slide. Anyway, so what I did was, I wanted a way of not having to be involved with the network guy when new services wanted to be stood up and new networks wanted to be configured. And one of the ways that we do our stuff where we work is we just use a new VLAN with a new network just to kind of segment services across. So I wrote a little script. There we go. So I wrote hacked a few scripts together and using Ansible to control the actual Cumulus switches and using the modules that Cumulus have developed. So it's really, really easy. So PyVMOMI, I think that's how you say it, is a very cool little Python script with a whole bunch of community added starter scripts that basically I grabbed one that goes through all the VMs and detects what VLANs they're on, and then turns around and provides me with a little file that I can then push into Ansible, and then Ansible can go off and configure the switches for me, which is really kind of easy. So it makes it to a point where when we start using Ansible Tower, we'll just be able to have the server guy go, yep, cool, I've built my new VMs and my new virtual switch and everything, and then press go and it will go off and configure the networking side of everything so that'll work. It's probably a good time to try and play the video so we can go see it.
I've got a couple more slides before we get to that.
Okay.
Let's see if we can go to the next one. I guess John can, so he'll be able to talk to us.
Yeah, so I'm back as well. So we've got basically your whole presentation that we had at Nutanix Next as well. So you should be able to just continue along. And I think for everyone kind of following at home, we did this presentation at Nutanix Next, and kind of apologies for some interruptions in our regular televised service there. My phone drops, but yeah, if you want to continue along, George, please feel free.
Sorry,
I was just going to say, isn't it ironic that the two participants from Silicon Valley dropped out, and the two participants that are halfway across the other side of the world have had no problems whatsoever?
That's how we do things in San Francisco. Right? Just go with the flow.
It proves the location independence.
So that's what my tiny or tiny web scale network looks like. This isn't obviously the full network, but this is kind of showing how we have our Cumulus top-of-rack switches that sit in both of our data centers. We've got that linked up with a 10 gig fibre, which is great. It means we can move things between our two data centers very quickly. And the kind of concept was when putting that in place and knowing that vSphere 6 allows cross-cluster vMotions and things like that, it was really easy for us to be able to push stuff across. We're also planning to use the DR replication parts of Nutanix, and that will be awesome. So fiber, like dark fiber through data centers, is pretty pricey. So my failover link is actually just a 1 gig over NPS quads, and that's been working really well and proved to to work when we drop the fibre. It does push over and we don't lose anything, which is great. So it's a cheap way of doing it rather than having to run multiples.
So correct me if I'm wrong here, but
go.
I mean, MPLS is pretty expensive in Australia, isn't it? Or is that you buy a managed link through another provider down there?
It's a managed link through a provider, and because I'm in their data centers, it's actually not too bad. They're quite happy to help me out with it.
Of course, I knew that before.
But of course you do. But I buy the fibre off them too. So they were quite. It was actually a suggestion from them rather than having to buy, 2 runs. It was like buy one, then just push the failover over there. So it has worked.
That wouldn't be Simon Dixon suggesting such things, would it?
It would be Simon Dixon. I bet he'd be Simon Dixon. Too early.
It's an awfully small world, I think is the message, right?
Yes, it is. So this beautiful slide, why we moved from SAN fibre channel hyperconvergence. Obviously, as I was saying before, it's simple. There's half as many components. It's faster. It really is faster. We had, when I moved Exchange across, I had people, like our old Exchange server, I had people turn around and just go, wow, that's faster. Phones were syncing faster with active sync. It was amazing. And it's really cool to see that kind of stuff happen. We even had servers that were getting the data so much faster that we actually had to up CPU counts in the machines just because they had more to process quicker. So it was a lot cheaper as well. Rather than buying compute and SAN and fibre channel and switching to rebuild. And it's also cheaper operationally because I'm obviously not taking up as much RU, a much denser solutions. Fewer moving parts, which is obviously one of the beautiful things about being simple. Fewer systems to update, learn, and teach. It's pretty important for us to be able to make sure that other staff members can do things on these platforms. You don't want to end up with a big IT department being very, very expensive with lots and lots of headcounts. So if you can have more generalists and be able to do more stuff with less, you're going to be able to deliver stuff to the business faster. And we've found that we've been able to do so many more deployments so much quicker on this platform than our old platform. And the Nutanix upgrades are amazing. New in the middle of the day. I even had one guy, Matt Day, while we're at Next, he was sitting there doing it from the other side of the world. So it's a pretty flawless update system.
What about your switch upgrades, George? Because they're pretty easy as well now, aren't they?
Switch upgrades are amazing. There's no moving another image across or anything like that. It is seriously on these Cumulus. It's apt-get, updates, upgrades, and they're done, which is awesome. And the other one was luck. Storage compute at the same time needed renewal, maintenance was coming out of contract, so it was like perfect time to throw out both and switch to something else.
So one of the questions I kind of had for you, George, did you have any challenges in deploying this, and roughly can you talk us through the timeline of how long this took?
Well, we did a lot of proof of concepts early on. So they were probably about 6 months out from deployment, where we just mucked around with the switches and made sure they were going to do what we wanted. And they did, and that was great. The actual putting the switches into the data centers was very much the weekend before Daryl, who's actually watching at the moment, before Daryl rocked up. And I configured them pretty much alongside the same time he was installing Nutanix blocks. And we had it up and running within a week. We did have one small, tiny little issue with one set of the switches, just because they were using a different processor and they treated the cables a little bit differently. But it was the fastest response I've ever had out of a support from a vendor. Shot the ticket across and I had a phone call within 15 minutes, and then it was moving along very quickly in terms of getting to the right people. It was with development very, very quickly. And so that was awesome.
So that's kind of an area I wanted to talk a little bit about in depth. Like obviously with complex multi-vendor solutions and that kind of thing, can you kind of talk us through how you actually acquired that? I think the Arena was obviously involved there. Obviously myself and Michael got involved in this at various points. But I mean, can you talk us through kind of the support process from both Nutanix and Cumulus, kind of how that worked? And obviously you had a evaluated kind of reseller involved there. Maybe just talk us through kind of your support process. And obviously you're one of the first people to do this, so maybe just honestly tell us how it went.
So if we were to go with the support, like if we were just to focus on the install, so Darryl was obviously there to install Nutanix and help us out and make sure everything's going great. When we did have problems, he was able to get in touch with the right people as well at Cumulus and Nutanix. And be able to check systems against other kind of things. It was really good. In terms of the support from Nutanix, we've had one or two little things pop up, and they've jumped on the ticket straight away, and we've had stuff within 24 hours. It was amazing. So the combination of having two vendors respond amazingly quick for support, you just don't get that. With Cisco, you'd end up probably talking to a level 1 TAC for a day or two. And that's the comparison I hold it to, because the rest of my network is Cisco. So,
well, that's no surprise, given that a lot of our engineers are actually from Cisco, Arista and whatnot. But I think the key message there is we have more CCIEs than we do people in our support team. So, so it's not a surprise you're speaking to some high caliber individuals, I guess, not being too salesy about it, but yeah.
No, they definitely know what they're talking about.
So George,
there was no time taken. Sorry, go for it.
No, it's okay. Just before we get on to where you guys are going to, could you tell us a bit about the decision making around the switch that you chose to put them on? Because Cumulus Networks being an SDN, basically software, you could have put it on any switch. So what was it that made you choose the Dell Cumulus switches in combination with Nutanix?
I didn't actually go down the Dell path. I went Quanta.
Quanta, sorry.
That was what the Arena had experience with and had used before. And the price point was amazing. It was very, very cheap. And that was probably one of the most key things. It was like, well, it's going to do what I want. It's going to have a platform which is Linux, which we all know. We've got more Linux servers than we do Windows servers at work. So that was pretty key to it. It was a beautiful bit of product. The Quanta switches had been used already, and people had given them the green light. So it was part of the kind of solutions that came through.
So I guess one of the points here is that the innovation is really in the software rather than the hardware. So getting that consistent software platform and having a choice of switch and having the whole integrated solution essentially interoperable and tested with the chosen hyperconvergence solution, because it means you've got less questions to ask when you're deploying what is essentially your most business critical infrastructure to run the medical labs and stuff in your environment, right?
Yeah, I totally agree. It has to be something that we know that's going to work, and knowing that both Cumulus and Nutanix both use each other in their labs to test is pretty impressive and important. You can kind of know that what they're doing, what both companies are doing, they're both using each other. So it's really, really kind of important to know that as two different vendors, but they're working in very close harmony with each other to make sure things work, which is very important.
So I might just, if it's okay, I'll just jump to slide 11, which has actually got our Nutanix performance labs on. This lab just happens to be based in Auckland, and it's the lab that I run as part of my role of looking after business. It's got a fairly enterprise class set up with a full leaf spine architecture. We're running Cumulus Linux with the MAG or CLAG feature, as it's called. And this was really dead simple to set up. I've tested with LACP connections from the switches, getting it set up, just a couple of simple configuration files, which is dead simple to then back up. And the reason I like leaf spine for Nutanix is because of the scale out nature of it. So it basically scales linearly. So one node at a time, and you can scale out the number of nodes just like you can scale out the number of switches. And this architecture is Ansible. I mean, you can even automate the installation configuration of all the top rack switches as well. From one of the switches, if you didn't want to consider. So because the switches are just Linux, so switches systems.
I hear there's actually an 8-year-old boy that's currently got his NPP that might be working on a lab in Auckland. Is that true, Webster?
Yes, that is true. My 8-year-old son studied pretty hard for his NPP, and he sat it the other night and he passed. So he knows the platform pretty well. This is how it works together. And when I'm traveling overseas, if there's ever anything done in my lab, I can basically call him my son. He helps me out there. So the infrastructure really is that simple to manage. Yes, there's lots of stuff that makes that. Pick it up and learn it. And I think that's the same with the switching with Cumulus, just as it is with Nutanix. You need to have those people with the infrastructure. You can have, any generalist IT person managing infrastructure, and the people can really get back to business. It's invisible, it just works, and then you just, go on and let the applications folks get on with what they do.
Yeah, I think your audio is getting a little choppy there, Webster, but I think we can continue on. So maybe, George, do you want to go run through your demo, and we'll kind of show that, and then we'll basically open it up with questions, I guess, from the audience as well.
Sure. Give me 2 seconds. I'll get the sharing working. Alrighty, can you see that video now?
Yep.
Yep, cool. Alright, I'll press play. Alright, so here we are just looking at the script I made, which hangs together a few different little things. It obviously uses this get VNet info Python script, which I've modified slightly, so the output's something that's quite usable for me. And it just kind of bumps these all together, sticks them in a little file which is used by Ansible, which will come up in a sec. So then,
how long did it take you to develop this, George?
Probably about a week and a half. So not a lot. It was just basically stuck together. We want to do a lot more with it. We want to do a lot more with the networking, a lot more with configuring routing and stuff like that. So there's the little script that the Ansible playbook. They're pretty simple. Bunch of variable files, the host list obviously, and then a whole bunch of these really cool, it's using one of these Cumulus modules, which just lets you kind of fill it all together. You have the interface name, ports, and what VLAN IDs you want, which it pulls all from these variable files. Then it goes off and actually reloads the networking on the switches so that it actually puts it into play. So the whole thing goes from the vCenter, pulls the information in, Ansible then will throw it out and configure it on the switches and restart. So here we go. Speed up a little bit.
Did you
just going through all the action. Sorry?
Did you require much help from the Cumulus team to put this together yourself, or would I think the modules you referenced were up on GitHub, right? So
yeah, so it pulled a bunch of information from GitHub. That was really the knowledge base articles that were actually on the Cumulus website were awesome. The demos and stuff, I kind of looked at how they did the demos that you guys do using Ansible, and basically kind of copied that. So I stood on the shoulder of the giants for this one. So this point in the demo right here is what my server guy would be doing. He'd build his port group, he'd configure his VLAN, go ahead and do that, and then once that's done and the virtual machine's connected to it, you would then go back, run the script. Oops, I'm going backwards. Why am I going backwards? So there's the VLANs before we run the script. SSL warnings, just we don't put up SSL, but it's good enough. And then it will spit out the new VLANs, and you can see it's picked up the new VLAN. And then if we go and run the Ansible, well, hang on, sorry, I'm on the switch now just to show that the VLANs on the switch aren't what we want yet. So you can see 56 is missing from there. And if we look at the interfaces file, so that there is, I think, probably really good to show. Just to do just the switch ports and VLANs, that's the only config file you need on a switch. So there's a whole bunch of other stuff with the MLAG and CLAG you've got to do, and multicast if you want, but that's in essence the easy parts of the switches. They're just the config file. It's not that scary. So if we then shoot back to the Ansible desktop, now we'll run the actual Ansible playbook. And off it goes, connecting the switches, working out what's already there. We do a backup, then we configure the interface and reload networking. And there you go, I've just configured the switches.
You said reload, right? So that shouldn't actually interrupt traffic, correct? It should.
No, it doesn't interrupt traffic. It just applies the config.
Yeah, so I think that's one of the differences between Cumulus Linux and regular Debian, is that we've got a package called IFUpdown2, which is written in Python and applies just the differences in configuration. So that's one of the things that module actually calls. So that's actually going to be upstream to Debian. So the whole Linux community gets to use it, not just Cumulus, but yeah, one of the things we've been working on and is used in this demo.
Yeah. There you go. So that was kind of the starting point of what we're doing. We're doing more with it, but it was very cool to not have to go into each switch, configure it, not have to go find out what it was. We can make that very easy, friendly, usable by server guys and Windows guys, which is really important about actually trying to make this architecture invisible.
So you mentioned invisible. Why? What's the kind of the goal here? Is to basically stop people from doing their jobs, or is it to increase your level of innovation? What's the reason for wanting to cut down that?
What we found before was it was incredibly, to get a project done, get a new server, get a new service working, new networking, it would take a lot of time, just purely trying to get resources like myself available to actually do some of that. If we're not having to provision SAN LUNs and configure fibre channel switches and configure networking as much and making it a lot easier for people to so if I don't have to be involved in a lot of those processes, we can actually adopt more new services and put more new things in faster and quicker. So it's all about making it, for my server guy, he doesn't have to come to me and wait for me, which is good. So he can deploy things faster and get more things done.
Cool. So yeah, so it sounds like letting you being a big part of the IT team, concentrate on higher level tasks rather than kind of configuration minutiae, I guess, if you will, right? Like working smarter rather than harder. We've all been in data centers for years. Obviously, I've spent my fair time debugging SANs and whatnot, and I'd rather put that time behind me, honestly. So I can completely understand. So I guess one of the questions I kind of had for you is like, there's obviously lots of different approaches to how to do this. So why did you choose this particular approach? What were the other options that were on the table, and what made you what made you take this journey, and then where do you kind of see yourself going in the next year or so as well in terms of Perth Rad's infrastructure strategy?
So one of the reasons why we did this was at the moment we've only moved all of our business applications across. The next step for us is we're going to be scaling it out and starting to store all of our images, because we store up to 10 years of images, and that's quite a lot. And we do it in both data centers. So if we lose the data center, we've still got a copy of images available to make sure that when the radiologists are reporting on these images, they've got all the prior history of the actual patient. So we can stop there actually and say, like, why is it the prior history is really important? Is it like for diagnosis and making better decisions and that kind of thing? Because I think, correct me if I'm wrong here, but I think you have some photos and images of my collapsed lung, which is kind of where we started this story, right? So maybe talk. I'll tell you that part of the story, I guess. Or part of that story was my lung collapsed a few years ago when I was actually in Perth, and I actually had to drive myself to the hospital because the radiologist that I saw first, basically couldn't admit me into an emergency ward in that particular hospital, right? So I had to actually get the printouts of the X-rays and drive myself to the emergency room. Maybe just can you talk me through kind of what Perth Rad's kind of setup is a little different and a little bit more automated, and obviously digitally delivering those images to doctors and that kind of thing, and how this kind of process has helped. So the reason why we try and stay online 24/7 is that we do service emergency departments. So we take X-rays and CTs in emergency departments of people that have had accidents and who aren't too well. So the radiologist who reports on that might not actually be at that hospital. All of our sites, we've got radiologists that specialise in certain things, and they may sit somewhere in particular across 15 sites that we have across Perth. And so we try and make sure that we've got high availability of those images everywhere. We need like a central spot to store them, and as Doug was saying, we need the historical stuff as well, because that's pretty important when you start looking at cancer and you start looking at also long-term diagnosis of conditions and historical stuff. To be able to pull up the prior imaging pretty quick, it's pretty important to know whether or not that tumour has actually gotten bigger or not. So if Doug rocked up today with another collapsed lung, which hopefully he won't, and was in Perth and he got imaged at one of our locations, we'd be able to deliver that image electronically to our referrers and the report, and also into any of the referrers, any of the specialists, into the emergency department over the wire real time. So it's a pretty quick process, and you need good solid infrastructure that's not going to die on you so that it works. And that's one of the main points of why we actually, we do put a lot of effort into making sure that the image storage is going to be something that's up and running and not going to go down. And having something that's web scale that scales out like Nutanix, we can add blocks as we grow and start storing more images, and we can adjust to the growth patterns of what we're doing. So if we start storing more, we just keep adding more storage. If we scale back, we don't have to add as much as quickly, but we can pretty much just keep growing out indefinitely. And that's a really cool concept where a lot of SANs may top out, or you maybe get really kind of not the density you want to be getting in a data center rack, because data center space is expensive. And so if you can store more in a space, then that's great as well.
Yeah, I think that's it's kind of really important, like I say, to get the density, get the collaboration happening between the various different components within the environment, and then sharing that kind of, using that same sort of collaborative platform approach kind of in the way your business is actually going to market as well, right? So you're able to concentrate on things, like delivering patient information and whatnot to the doctors in their hands in an emergency department, when they actually need it. So it really is mission critical kind of applications, right? But we're not talking about, this is not quite life and death, but it's pretty damn close. So it is. It's getting the right information in front of the right person at the right time, with a scalable infrastructure at the back end that that can deal with problems. And obviously, like you said, we've spoken about support and that kind of thing as well. So if something does go wrong with that infrastructure, it's not the end of the world if something does go wrong, because you've got plenty of other nodes to take over the load. And then you can kind of come in there and, with really good support, fix the problem in a timely manner. So, I think that, like, obviously I'm kind of testament to that. I mean, I've been to this radiology clinic, when I was back in Perth many years ago. I've seen what it can do. And obviously, it's obviously going to be, this is a value that Perth Rad Clinic has obviously got above and beyond some of its competitors, right? So this is something that actually your infrastructure is what makes Perth Rad Clinic, slightly more competitive and doing so well in that market. Is that kind of fair to say, or?
Yeah, I definitely hope so. It justifies why I'm there. If we didn't have, if the network goes down, sadly the entire operation kind of does stop. So it is pretty important to have all this working. If we can't get an image from, the hospital to in front of the radiologist, we have to drive the radiologist out there to do other things. It's not an ideal situation. So having, a network that's going to respond fast and have the infrastructure sitting in the data center that we know that's going to be able to handle having a node die, which, that stuff happens, but I think there's a quote somewhere I heard that software will eventually work and hardware will always die. You occasionally have hardware stuff die, but the best part about the software that runs the hardware these days, it's resilient. If something does die, other things take over. And the support from Nutanix and also the partners. So B Arena, we did have a node die, and B Arena had us up and running again within a day or two. And that was completely replacing the node and having everything back online. But we didn't lose a single service. And there was no performance hit that anyone felt. So it was awesome.
So let me just quiz you on that again, George. Hopefully you can hear me now. You had a node die in your cluster, and there was no impact to performance. There was no impact to any of the services that were running. And the restoration process for that was seamless and non-disruptive.
No one knew. And that's the really cool part. If you can have a whole thing die, a piece of hardware die and nothing takes a hit from it, that's a pretty damn cool architecture in my book. Means I don't have to worry about it too much. If we do, we can do upgrades in the middle of the day. You get your weekends and your evenings back a lot, because you can do stuff on this stuff during the day, because it's the abstraction layer is just so tidy.
I suppose the other thing is you can because this is all it's the web scale kind of approach, I guess, of having everything presented through GUI, sort of a nice web GUI and whatnot, but with a Linux-based back end. You can do this from anywhere. I know you've done it from San Francisco. I've seen you do it. I've seen you manage this infrastructure from Miami. I think it affords you a lot to you can do this from anywhere, and it means you can start hiring global teams as well, right? And have follow the sun models and all sorts of things. You can do any of that with this kind of infrastructure.
Yeah, it definitely is accessible. You don't have to have some weird Java application that will only talk to this version of that software on that router at that time. it's all presented through web browsers, and that's really cool with Nutanix. It means you can just go in someone's, you can grab any desktop around the place, jump on and have a look, and know whether or not stuff's working or not. That's quite nice. There's no client. And yes, you can manage it from anywhere.
and you have. I've seen it. So I guess, I'm not actually seeing a lot of questions from the audience at this point. So we did have a few minutes left for Q&A. So if there's any questions, feel free to ask them. And in the meantime, if Webster, if you've got any further questions, maybe do we quiz George a little bit more?
Yeah, I'd like to just talk to some of the integration pieces that we're doing. We mentioned briefly, and some of the attendees may not have heard it, but Cumulus in San Jose. Nutanix tests with Cumulus in our labs. As well as some in the top rack switches, operating system in the Nutanix software, so that you can really get a single visibility across the entire infrastructure. So yes, the infrastructure is going to be invisible. It's going to be running itself, as we heard from George. It's going to self-heal. You're not even going to notice when there's a failure. But if something does need to be investigated, you want to have all that information at your fingertips in one place, so you don't have to go through multiple consoles to find out what's going on. And this is why we're extending the visibility inside of the Nutanix Prism to actually get on the switching layer as well. And at this stage, MP and standard calls to the top rack switches, and that ordered hypervisor at the moment. We're rolling out integrations with the switches that we're doing the work with. We've also got our Nutanix to actually get a high level of validation and everything with the actual Nutanix platform as well as the switching infrastructure. So it's more than just it's more than just testing. We're actually doing integration as well.
Yeah.
Yeah, I think we got most of that. So, it's great to hear. Obviously, straight from kind of the horse's mouth, I guess, from Nutanix having the Prism UI, integrating with with Cumulus and kind of other vendors as well to show back that kind of that kind of level of information. So I think Vasudha, do we have any other questions, or would you like to wrap this up?
Sure. We have one question. Were there any other pieces of the puzzle required outside Cumulus and Nutanix and the ODM switch, like management software, optics? This is one of the questions from the attendees.
Great. Optics, I think we can probably bang on for a little while there. George, if you want to sort of talk about obviously your MPLS ring and what is the cost of kind of locked versus unlocked optics, that kind of thing? Did that help in this decision-making process? I think the management software, obviously, you can talk about as well.
Yeah, so management software, as long as you've got something that can SSH into the switch, so PuTTY or a terminal session or SSH on a client, that's pretty much the way to jump in there and manage those switches. If you want to use something above that, I have heard of people using, and Doug can correct me here, webmin that may give you some ability if you really want a GUI, but the actual config files are so simple. It's the same setup as a Linux web server in terms of its network, addressing and stuff like that. So there's no real management software that you really need to run one of these switches. In terms of optics, because we don't have to use the Cisco Genuine or insert vendor name Genuine optics, you can use grey market stuff, and it is a lot cheaper. And that does make the price difference when you sit there and go, okay, this is a vendor, one vendor's solution, and they're telling me I have to buy all these optics and all these cables that match what they need. And then you go to the other one and you look at it and you go, okay, so Cumulus is going to need that and the support for ridiculously cheap against anybody else, and then turn around and go, yeah, okay, you can use whatever optics you want. And I haven't found an optic that hasn't worked. I've been pulling stuff out of drawers randomly and going, oh yes, if that works, and that has worked. So in terms of optics, they're very flexible, and I think they'll even, in speaking to one of the engineers from Cumulus, was like, if you do find an optic that doesn't work, let us know and we'll make it. We'll do everything we can to make it work. So that's one of the cool things about it, is that it's been cheaper to put everything in place than with a lot of the other vendors that we looked at.
So I think the other thing you kind of touched on there is, like, the reason for that being cheaper is that you've got more competition at that space, right? So you can choose 10G tech, for cables and whatnot. You can use obviously most storage arrays, including Nutanix or Hyperconvergence platforms, come with their own DAC cables. So those are all obviously already included with the box. And when you want to do anything kind of funky like the MPLS ring and whatnot, you've usually got a choice from multiple different hardware providers, right? So you can choose to buy Finisar, or you can choose to buy something else. It's kind of up to you. But because you have that choice, there's competition there, and the price is generally lower because you're not locked into anything. So I guess in terms of the management software, the management software though, you created some management software there, right? Using Ansible.
So yes.
Effectively, you don't need third-party management software, although you can choose to find some off the shelf. Anything that kind of runs a software agent. I mean, in general, the answer that Cumulus would usually give for what software do you want to run on a Cumulus switch is, what are you doing on the server side? It's just the standard answer to almost every question. It's if it's management and monitoring, if it's alerting and kind of and automation, the answer is always, well, how are you automating those thousands of servers you might have, or how does your Googles, Facebooks, Amazons, and yada 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 of the world do that? Do they log into individual switches, or do they write a piece of software that SSHs in or has a software agent on it? It's pretty simple. It's the latter.
I was just going to add to those optics. Sorry.
Go.
I was going to say, just one thing with those optics is, to do some of it, I actually just pulled the stuff out that was in a Cisco switch there that we just took out of production, and the optics were still good because they slid right in and fired up and lit up. So it's very happy to take any kind of optic.
What about the management of the Nutanix infrastructure? Did you need to use any additional management tools like hypervisor? Running ESXi, did you choose to use vRealize operations or anything like that, or did you mainly use vCenter to manage the VMs and just Prism to do everything else?
We've actually, it was on the cards. We're looking at the vCenter ops or Realize, because we wanted some kind of visibility into things just to see how things were running. But we don't need that anymore. The stats we get out of Prism tell us, what VMs are running hot, too hard, what are doing some silly I/O, what aren't doing silly I/O, very, very quickly, very, very quick, easily. Especially when you've got so I've got two clusters, and then there's Prism Central, which then aggregates the information from both, which is really, really cool. So no, you don't need any extra tool to do this or to do that. You do get a lot of information straight out of Prism that will tell you the health of your machines very quickly. If that answers your question.
Yeah, it does. That's great. Thank you very much for it.
Okay, great. Thank you, Doug, Michael, and George. We are actually running much over the time. Thank you, everyone, for your participation, and thank you, Michael and George, for dialing in at this ungodly hour for the webinar. We hope that the attendees found this presentation about open networking for hyperconvergence useful. We'd love it if you offered the feedback via the follow-up emails. Please tune in to our next webinar on L27 for your OpenStack on July 21st with Nolan Leake, our CTO, and Mark McLean from Akandan Inc. The details are available on our website at cumulusnetworks.com/webinar. Thank you for your time today. We look forward to seeing you at our next webinar.